This is the ideal gas. So the ideal gas law uses this equation. So anytime that you're working with gases, there are a couple of assumptions that we are making. One of the assumptions is that we're making is that the gases are kind of going to be inert and they're not reacting with each other. Now that's going to change when we start taking into consideration stoichiometry. Okay, and we'll get to that point today, hopefully, or if not today, on Thursday. Now, P is going to be your pressure. B is going to be your volume. N is going to be your number of moles. R is going to be your ideal gas constant, which it is. And T is going to be temperature in Kelvin. Okay. Okay, so the ideal gas constant just gives you this nice equation to sit there and let us understand the relationship between pressure of a gas, volume of the gas, number of moles of a gas, temperature of the gas. Okay, so if we take a look at this, and we could say under certain circumstances, we have things that are going to be consistent. So if we have a container that minimizes our volume, so then that means our volume isn't really going to change. Okay, so in that case, then we can sit there and say that the volume is going to be constant, right? So if the volume is going to be constant, we can sit there and arrange this equation. And T, we know that R is a constant. To solve for R, we know that R is a constant. So then I could sit there and put ones here. And say that this constant is also equal to another situation where we have a different pressure, a different volume, and a different temperature. So then I can sit there and set these guys to equal to these two equations equal to each other. Okay, so I can set these equations equal to each other. And this allows me to sit there and have some flexibility. So if I'm given a temperature and I'm given another temperature, I'm given a volume, but I'm not given this other volume. And they tell me that they want me to calculate the volume at that other temperature, but they also tell me that the pressure is constant. Meaning it's not changing at the different temperatures, and the number of moles. We're using the same number of moles of whatever gas we're looking at. They're going to be constant. So if pressure is going to be constant, so I could sit there and say P1 is going to equal to P2. And essentially, I can just cancel them out. Okay. If number of moles are constant, that's N1 is going to equal N2. And then they can also be canceled out. So then I'm just left with V1 over T1 equals V2 over T2. Okay, so this is one way that you can use the ideal gas law. In your case, all you're doing is trying to calculate the number of moles. Am I correct on that? Number of moles of gas that you're generating, right? So then you just need to use this original equation, and you need to solve for N. Same equation that we use for when we were doing the balloons, right?
Yeah, the lab does ask us to predict the volume.
I thought it was
okay.
volume.
So in that case, you're solving for V, right?
Yeah.
Even better. Okay. And since you're kind of open to the air, you're going to assume that the pressure is going to be 1 atmosphere. And your temperature is going to be dependent on the temperature of the room.
Okay, how do I know?
What was that?
I was going to ask, how do I know the temperature of my room? Because I don't keep count of, I don't track it.
Well, it's real simple. You can go to weather.com, check the temperature of your area, and assume that the temperature of your room is within a couple of degrees of that, right?
Okay. Okay.
Or you can take a thermometer in your room and then get the results.
Yeah.
Okay. Questions, concerns, Cash? Does that help, Brianna?
For the temperature, do you want it in Kelvin, right?
Temperature should always be in Kelvin.
Got you.
Dr. Henry.
Yep.
Okay, I can't write out the chemical equation.
Why can't you write out the chemical equation?
Well, okay, I don't know. I can't. Like, am I going to be like from what was the first step I did? I don't know how to write chemical equation. I don't know if you
need to start figuring that out, right?
Yeah.
At this point, you should be able to write chemical equations like the back of your hand. And if you don't,
I can write chemical equations. I don't just know the formula of like the chemicals and stuff like that. Actually, I'll browse it. I'm kind of just being lazy.
Okay.
Yeah.
So stop being lazy then.
Yeah.
That's the easy answer, right?
Yes.
See, I like honesty. At least she's honest about it. She says,
yeah,
well, it's because I'm being lazy. You know?
Yeah.
Okay. So
Yeah.
you need to be sure of that, because on the exam, you know,
Mm-hmm.
it's going to be a whole bunch of chemical equations. And if you can't write them out, if you can't figure out the formulas, you should be able to figure out the formulas based upon the knowledge that you guys know. Everything that we've covered, then you need to be going, you know, spending those evening nights instead of watching TV. You should be watching CHEM-002A videos, right? Or watching porn, you should be watching CHEM-002A videos.
Okay.
Okay.
Dr. Henry,
Yes.
is it at all possible if you got a small extension on this?
No. What did I just say? Earlier, I said the first thing, you'll have an opportunity to turn in all your labs by May what?
21st.
Okay, so after this, I'm not going to tell you. I said, so does that mean you have an extension on this one, Tucker?
Wait, say that again. I couldn't hear you.
I said, does that mean that you have an extension on this one?
I guess, yeah, it is. Yeah.
It does, right?
Yeah.
I wish
Okay.
I had a shock collar sometimes. I just go.
Okay. So yes, you
Okay.
are giving us an extension for you. Thank you. Thank you for the extension.
Okay. So again, your homework assignments, your lab reports, all of them, they're due. I'm going to start going through everything on the 21st. Okay. If it's not there by the 21st, then I'm putting zeros. Okay.
Wait, real quick. What about because you said like once our like say a grade on the final grade on the test, you have a week to do like where you get half credit.
Okay. Yeah.
Um,
So you have the option. I should be finished grading all your exams by Thursday night. So Thursday night, you can use any of those 3 exams and do your test correction. Okay. So any one of them. So I just finished. I finished Kalinga's first exam. It should be all done, except there's probably 2 people that I sent messages to. Hopefully they'll look at those messages. So if you want to do your first one, which I'm looking at those first exams and I'm starting to look at some of the second exams, and it looks like your first exams were a whole lot worse than your second exams, I would definitely think about doing that first. Okay. And then your third exam, you pretty much got your points automatically at the end, right? So that's pretty much all the points. I think there's only one little short answer question that I have to look over, and then I have to fix the question that didn't have the images, right? So you would just assume that the one that had the screwed up images, you guys are going to get points for those. Okay.
Dr. Henry, in the previous exam, I got screwed up images too.
I know.
Yeah.
And I don't know why. I'm having a lot of trouble with Canvas and images right now. So I can't explain it. And I don't know if it's something on my end or if it's something on their end or what, but it is what it is. We can do the best that we can do. Unfortunately, I will try to get a solution for the final because there's typically a lot of images that pop up on your final.
So Dr. Henry, I'm sorry. So you are giving us an opportunity to fix either the first or second exams if we had a low score, right?
That is correct.
Okay, and we're only doing half points on that, right?
Yeah. So you know the rule. It's you go through the questions, and it's all the questions that you got wrong. You have the potential of getting half those points back.
Okay.
So, but you also have the potential of losing whatever those points that you did get wrong if you don't follow the instructions and you blow smoke up my butt.
Okay.
Dr. Henry, what of Chem 101?
Excuse me?
What of Chem 101?
What do you mean by what of Chem 101?
Are you opening it up, the assignments also?
Okay, so Mary, Tucker, can you tell Mary what I just said?
Okay.
Open till what about when they're open the 21st?
It's going to be open up until the 21st. We'll be opening it up tonight.
Okay, I just wanted to know if Chem 101 was included.
Yes.
I heard that. Yeah.
Okay, any other questions? Okay, good. So are you guys feeling comfortable about ideal gas laws?
Sorry, but I have a quick question.
Okay.
Were the instructions posted for the exam corrections?
Yes, they're posted in the syllabus.
Okay, thank you.
No problem.
I actually have another question. Sorry, Dr. Henry.
Okay, that's all right.
I messaged my group. It's two guys that I have on my group for the group project. And well, they haven't gone back to me since April. And I've been doing it all by myself. But how would that work?
Then you just do it all by yourself, right? And
Okay.
you get the opportunity to give them a grade on what they've done. And you give the presentation, you sign up for the presentation. If they don't show that, that hurts their grade, because then I see directly that they put no effort into the thing. So then I give them a really bad grade based upon their presentation.
Okay.
And then you give them a bad grade because they didn't do shit. So
Okay. Thank you.
Just like the real world. If you have a job to do you sit around and wait for other people to get it done, or do you get it done?
You
I
get
get
it.
it.
done. Get it.
Any other questions?
Okay. No, that's it. Thank you.
Okay.
Dr. Henry, so in the Chem 101, since everything is getting opened up again, so we can go back to the questions that we missed due by using all the attempts? So there will be new attempts, or?
There'll be added attempts onto it. Yes.
Okay. Because there was two Chem
And
101.
that's why I said we're going to need a little time, and I'm going to need Cole's help to go through that, because I have to go through each assignment and do each one independently. Bear with us. We'll get them up.
Okay, then.
Well, Dr. Henry,
Yes.
of our total grade at the end of the semester, how much percentage is Chem 101?
Okay, so this is what I hate. I hate those questions, but I'll tell you anyway. Chem 101 is going to be 10% of your grade. However, if you're at a C, that 10% means a whole hell of a lot, right? So and then also it gives you some practice for some of the questions that you know that you'll probably see on the exam.
Yeah,
So,
it gives lots of practice actually.
Double-edged sword, right? Your presentation, your group presentation is also 10% of your grade, right?
Okay.
So, but if it were me, I definitely make sure I get my test correction in, because I wouldn't want to waste that. That's a kind of somebody's giving me a chance to get an F to a C. Hell yeah, I'm going to take advantage of that, right? So I'm going to make sure I get that done. I'm going to make sure I get my group projects done, because my group project is kind of simple. It's a 20-minute presentation, 20 slides typically, right? And then you just got to know the material and be comfortable with the material. You get a chance to talk and shine and show me how talented you are, right? So then that's a pretty easy give me points, right? Not
Is
too
it
hard.
20?
You're not being, grilled with proctorial or anything like that. So that should be an easy 10%, right?
Okay. What
And
of the
then-
page?
What was that?
Sorry for obstructing you though. What of the page?
Yeah, the page is also included in that, right? That's just still should be easy, right? Because that's just facts, right?
Okay. Just
Isn't it?
facts.
It's just facts, because that's all it is. It's facts, right? You're putting the facts on there. You're putting truths, right? You're not making anything up. You can be creative. Anytime you're creative, that's always an added bonus, because that helps you make sure that you get that A instead of that B or that C, right?
Mhm. Well, you also said something. You said it's 20 slides. Is it 20 slides or 20-minute slides?
It's
Or
20
30
minutes.
minutes.
But on the average, most people talk fairly fast, and you assume that it's going to be about 1 minute per slide, usually.
Hmm.
There will be I'll be opening up a general link for the test corrections for you to submit the test corrections. I just have to adjust the date for it. Okay, so there'll be one link for all test corrections. You all submit them there, and I'll take a look at those at the very end. Okay. Yes, of course you have to citate. You have to use citations, Mike, because this is the real world. What happens if you don't cite somebody and you take their work?
A garrison.
You get sued. Do you guys want to get sued?
No, not at
I'll
all.
turn your asses in a heartbeat. As long as I get a cut of the money that they're going to get from you for suing you.
Okay.
I do have one question. How would you like them cited? I think I missed that.
Okay, so we're okay. So you can use MLA. That's acceptable. Okay. You can also use the APA, which is the
American Psychological Association.
Yes. So their citation is something that's commonly used in sciences, and it's the same one that is pretty much used in all sciences.
Okay, cool.
Yeah, it's clear that Nate isn't here because he hasn't had a little comment yet.
Exactly.
Let's see. What else? Copyright. I don't believe I said 20,000 words. If it's 20,000 words,
I was about to say I'm screwed.
yeah, I'm not reading it, you know? And so if I don't read it, I'll just put a 0 on it, so.
Oh wait, so the web
Oh.
page, how many words is it's 2,000?
2000.
2,000. Oh,
Not 20,000.
oh gosh. Okay, thank you.
I like that. Victor, that is creative. So you're asking me if you can cite a YouTube channel since the lectures are uploaded. Yeah, I guess you can cite it. That would be a citation for it. But you should have more than one citation, right? I don't want to hear big bold letters that say YouTube, right? You need a little bit more than that. Yes, it is 2,000 words. It is not 20,000 words. Okay, let's see. What is the page? Oh, okay, so at the page, so you have 3 parts of your group project. You have the presentation, you have your parody, and then you have the page. The page is all of the factual information, because how many of you guys have given a presentation?
I have.
Yes.
Okay. So we know that when we give a presentation is just a synopsis of all of the material that we basically learned, right? Or all the material that's out there, because you can't get it all in that one presentation. If you do, that presentation is typically like 18 hours, right? And none of us are going to sit here for 18 hours to watch you give a presentation. I may like you guys, may love you with all my heart, but sorry, I don't like you that much. Okay? So that 20 minutes is a condensed version. And what you guys are putting on that page is the expanded version. You're giving me all that information that you didn't quite cover, okay? All the nitty gritty in those details. Does that help?
So like the key points and the little summaries.
Yes. And images, remember, pictures make things so much better. Well, let me rephrase that. Relevant pictures make things so much better. It's easier to go through materials if you have, examples, and if you have pictures to kind of help us through it. So you want to sit there and make it a little more interesting. That's also the same thing with your presentation. Visuals help quite a bit. That's why you guys are always on Instagram, right?
Well, not anymore.
What was that?
Not anymore. I deleted Instagram.
Oh.
I'm trying to be healthier now. This quarantine has been no.
Okay.
But I see what you mean. Pretty pictures and big key points.
Yep. Any other questions? I told you, strong assets. How do we recognize a strong asset?
When it completely, I think it's dissociates in water.
When it completely dissociates in water, that's going to be a strong acid. Okay. So the example that we give here is hydrochloric acid. You guys can see strong acid, right? So this is the ionization, percent ionization. So we have 79% ionization at 0.01 molar. Now, this term is called molar. Molar or molarity. Molarity is just the number of moles over the total volume. Okay, so usually this is a solution, right? So we'll put what we call a solute in a solution, right? Solute is the thing that's typically less of, and you put it in a solution, and your solvent is what kind of dissolves it. Okay. So another way of looking at it, you have quantity in a solution, right? So like if we had a whole bunch of little balls and we put it in a big old tank of water, or how many guys went during Halloween well, probably not this Halloween, but when you were a kid, you would go bobbing for apples, like at the local, I guess, haunted house or something like that, and they had the smoke and stuff coming up in it.
I've
Anybody
never
did that?
celebrated Halloween.
You went to anything Halloween?
Never celebrated Halloween. We don't celebrate it here.
Oh, okay. Sorry. Well, you have to come to the States, and then I'll take you guys bobbing for apples, right?
Okay.
So in that case, you have a whole bunch of little apples in this big old tank of water. You have so much water, and then you have your apples relative to your water is a lot less, right? And so your apples are sitting there floating. In a sense, that's kind of like a solution. So molarity would be the quantity of those apples over that total volume, okay? That would be kind of the equivalent of molarity. Does that make sense? Excellent. Okay, so when things dissociate into their ionic components, they're able to conduct electricity. And we've talked about that. You guys are familiar with it. This is just basically showing you the equation. This basically shows us that the equation can technically go both ways, but it favors going in this direction so that we have more of the ions rather than the acid, okay? And then this guy, hydrofluoric acid, is a weak acid. That means it doesn't want to dissociate. It wants to stay together because we know that fluorine is very aggressive and strong and abusive and won't let hydrogen go. It's like hydrogen is his woman and not going to let him go. Going to stay right next to it, right? And so because of that, they're not going to dissociate, stay together because fluorine is so electronegative. It doesn't like to let go, okay? In this case, this guy's going to have poor conductivity. And then we're going to be favoring, if you look, the arrow is going longer in this direction. We're going to be favoring when they're together, not when they're apart. Does that make sense?
Yes.
Yes.
Hold on 1 second, okay? Okay, sorry, got babysitting duty. So, okay, so we were talking about that dissociation. So we know that hydrofluoric acid doesn't want to dissociate. It wants to stay together, okay, because that fluorine is so strong. And so majority of the solution is going to be staying together, but you're going to have just a little bit that is going to be able to separate, okay? Are you with me?
Yes.
Good.
Yes.
Okay. Oh yeah, this is chapter 9, by the way. Okay, so we make reference to minor species. Minor species are the ones that are the less, right? So when we have a strong acid, the minor species is the hydrochloric acid that's together. The major species are the ions. So we have more of these guys than the compound that's together. Where in the case of the weak acid, we have more of the acid that's still together than the ions. We have a little bit of that. So minor means you have the majority of it. Major means you have the majority of it, and minor means that we have the least of it. Does that make sense?
Yeah.
Okay, so these are 7 strong acids. So nitric acid, sulfuric acid, hydrochloric acid, hydrobromic acid, hydroiodonic acid, your chloric, your chloric acid, and your perchloric acid are all strong acids. So typically when you have a per, it's going to be a strong acid unless it deals with a carbon. All carbons are going to be weak acids. If you have an ic at the end, it's typically a strong acid, although hydrofluoric acid is an exception to that. Okay? Okay, so all carbon acids are weak acids, and typically things that have ic are going to be strong acids, unless they're a carbon acid. Carbon acids, all carbon acids are weak acids. Okay, and we also know that hydrofluoric acid is also going to be a weak acid. Okay, are you guys good with that?
Yes.
Yes.
Okay. Okay, so if it's OUS, OUS are typically weak acids. Okay, so anything that's going to have OUS is going to be a weak acid. So write the formulas for the major species in solution of nitrous acid and fluoric acid. Okay, what is the chemical formula for nitrous acid?
Nitrous acid. Nitric acid.
Nitrous acid.
Nitrous acid. Okay.
What's the
HNO.
chemical formula? I heard somebody say
That'll be the nitrate one.
HNO2.
HNO2. Okay. So, is this a strong acid or is this a weak acid?
Weak.
Okay, so we know it's a weak acid. So what is going to be the major species? Is it going to be this, or is it going to be?
The acid is going to be the major species.
Okay, so then this is going to be the major species.
Why would it be, Dr. Henry?
Because it doesn't dissociate. It doesn't want to dissociate. So you're not going to have a lot of them dissociated. Weak acids don't dissociate.
Okay,
but why is the weak one circled then?
Okay, because we're talking about the major species. Major species meaning that what is going to be in solution? What are you going to have more solution of? Because when we put stuff in solution, you technically have both things available, right? We have both this guy and we have this guy, right? So they're both going to be in that container, right? But you're going to have more of these than you're going to have this because they're not going to dissociate too well, right? So major just basically means you have more of them present in solution. Does that make sense?
Yeah.
Yeah.
Okay. So what about hydrochloric acid? Chloric acid. So what does chloric acid look like?
HCl.
HCl.
O3.
HClO3. Okay. What is it going to dissociate to if it dissociates?
H plus and ClO3 minus.
Okay, so what is going to be the major species?
It's going to be the ions.
Okay? Simple?
Yeah.
Okay. Okay, so up until this point, we've been working with what we call the conventional equation. The conventional equation basically writes it with everything together, right? But in reality, when things are in aqueous solutions and they can dissociate, they're going to dissociate. And so we're going to learn how to write what we call the total ionic equation. And the way that we do that is anything that can dissociate, we're going to dissociate. So in this case, this guy is in an aqueous solution. We know that it's an ionic compound. We know that stuff in an aqueous solution that is an ionic compound can dissociate into its ion. So what will be the charge on the lead for the lead nitrate, lead 2 nitrate?
Charge of 2.
So it's going to have a 2 plus. So because we're dissociating and there's 2 nitrates here, those nitrates are able to act independently. So they're going to be, you're going to have a coefficient representing 2 nitrates that you have. And we know the charge on nitrate is a minus. Okay, what about sodium chloride? Is that going to dissociate?
Yeah.
Okay, what am I going to get?
Any 2 plus 2 Na plus.
Okay. And you don't want to forget our aqueous.
Yeah. Then
And
2 Cl minus.
okay. So anything that's a solid or a gas or a liquid isn't going to dissociate. It's going to be stuck together, right? Because the solid doesn't break up into its ionic component. It stays together. So here, the lead 2 chloride is going to remain together. But the sodium nitrate is going to separate. Okay, questions, concerns, cash, credit? And again, this is called the total ionic equation.
Dr. Henry, one
Yep.
question. For the PbCl2,
Yep.
why is that one not separated?
Because it's a solid. So if it's a solid, liquid, or gas, it won't separate. The only time that it'll separate if it's an ionic, or I'm sorry, if it's an aqueous solution. Okay,
Thank you, Dr. Henry.
no problem.
Dr. Henry, when we have these questions, if it's a salt, like, will there ever be an instance where we cannot, like, we'll have to assume whether it's a solid or not, or will there always be, like, because if you didn't have that S there, I would know it's a solid.
So that's going to deal with solubility, and we'll be talking about it. Okay, so yes, you're going to be able to determine whether something is going to be a solid, meaning that it won't be able to separate. Okay, or it'll be given to you in the question. Okay, and anytime that they don't specify, like said that they specify, they say something is precipitated. Anytime that something is precipitated, that means it forms a solid, right? That means it forms a solid even though it's in a solution. That means you're going to use an S for that. So, does that make sense?
I think so.
Yeah. Okay, so precipitation means formation of a solid. Okay. So the next thing that we're going to do is determine the net ionic equation. Okay. Have you guys ever went to a party with somebody and they go to the party and they just stand against the wall? They don't talk to anybody. They don't do anything. You know, they just stand there. Anybody done that?
Yes.
Yeah.
Or what about
Okay.
somebody sitting in a corner or in a wall?
That's the same thing, right?
Yeah, I was about to say that's probably the same thing.
Yeah, that's exactly the same thing, right?
Yeah, I've seen that before.
So what we call those people are, we call them spectators, because all they came to the party for was to watch other people have fun, right? They didn't want to have fun. Okay. So with the chemical reaction, you have what we call spectators as well. So it's those that they look exactly the same on both sides of the equation. So for instance, if we look here, we have the nitrate here, and we have the nitrate here. We have the sodium here, and the sodium here, right? But the lead and the chlorine, they got together, right? So they're not spectators. They're enjoying that party, right? They're hooking up and leaving together. So, okay. So in this case, these guys are spectators. So really, all they were there for were to bring the other two to the party, right? So the other two could hook up. Okay. So in that case, the net ionic equation is going to be lead 2 ion plus 2 chloride ion yields lead 2 chloride. And this guy's called the net. Okay, because you're just getting rid of the spectators. Okay, because the spectators are just sitting around; they're not there for anything. Okay, they did their job by bringing that person to the party, and that was it. Okay, you guys get that? Yeah, no, maybe. Piece of cake.
I think, yeah.
Okay.
I just don't. I think I get what you just did right now, but before you got to that part, when you were breaking down from off the example, like I'm just picturing this example without the AQ or the S, and I know I would be lost.
Well, the more you do it, the better you'll get. Okay.
Mhm.
So I'll make sure to give you guys, I'll adjust those problems so you have quite a few of those. Okay.
Yay.
Okay. So. Okay. So the first thing that you always want to do is write your conventional equation. You want to get it balanced, and you want to put in the state symbol. Because if that's wrong, everything else is going to be wrong. Okay. We know that what's going to break up? Acids are going to break up if they're strong acids. We know that ionic compounds that are in solution are going to break up. Okay. You always want to reduce your coefficients to the lowest term. So at the very end, your net ionic equation, you want to make sure that you have everything reduced as well too. Which if you have everything balanced, usually it works out perfect, usually. Okay, so let's test this out. When a strip of magnesium metal is placed in an iron 3 chloride solution, a magnesium chloride solution results and solid iron also forms. Develop the net ionic equation for the reaction. Okay, so first, let's write the conventional equation. Okay, Mary.
Me.
Work on that equation stuff, right? So it says when a strip of magnesium metal is placed in an iron 3 chloride solution. Okay, so what is going to be my reactant?
As in the chemical equation.
Yes, as in the chemical equation. What are going to be the reactants?
Okay. Magnesium solid metal, obviously.
Okay, so what is the symbol for magnesium?
Mg.
Mg. And I use what for solid?
S. Subscript S.
Okay. And what else am I reacting?
That is an iron 3 chloride, which I guess is okay, give me a second, please. Iron 3 chloride, that should be FeCl3. FeCl2.
Nope. You had it right the first time.
3, okay.
And it's a solution, so what am I going to put?
Okay, that's AQ subscript.
Okay. Okay, Sal, what is going to be my products?
Dude, I'm blanking out. So we have magnesium, iron chloride 3.
Is it going to be the magnesium with the chloride?
Okay, so what would be the chemical symbol for the magnesium with the chloride?
Mg.
Mg.
Cl.
Cl.
3.
Cl2.
Didn't it cancel because magnesium's
Cl2, that's right. I heard, who was it that said Cl2?
Me.
Yeah, because we know that magnesium has a +2 charge, right? Because it's in group 2.
Okay.
Periodic table, everybody remember that?
So all those stuff apply.
Yes, everything that you've learned, you can't throw out the window. You're supposed to be applying it, right?
Yeah.
Okay, so is this a solid, liquid, or gas, or aqueous?
Solid.
Aqueous.
Oh shoot.
Aqueous. Because it's a solution.
So solution will always be aqueous?
Yeah, solutions are always going to be aqueous unless they tell you otherwise, because 9 times out of 10, you're going to have your solutions going to be in water. Occasionally, you'll have it in ethanol, but they'll say in ethanol. And then that's a little bit different, okay? Or some other solvent. It's always water otherwise. So if they don't tell you anything different, assume it's water. So you just put aqueous. Okay, and what else? What is the other product?
Fe, iron.
Iron.
E.
Okay, solid, liquid, gas, or aqueous? Bless you, who's ever speaking.
Solid. A solid.
Okay, so is this a balanced equation?
Well, no.
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 Okay, how many magnesiums do I have on the reactant side?
1.
That's 1.
1.
How many do I have on the product side?
1.
How many iron do I have on the reactant side?
1.
And on the product side?
1.
How many chlorines do I have on the reactant side?
3.
3.
And on the product side?
2.
2.
Okay, is that balanced?
No.
No.
Okay, so I need to balance it. So what do I need to do to balance it?
Add a 3 to MgCl2 and a 2 to FeCl3.
Okay.
Yeah,
So then that gives me
6.
okay, the chlorines are balanced, but now I have 2 iron and 3 magnesium.
Yeah.
Okay, is that balanced?
No.
No.
So you just complete it. You add that's 2
Yeah,
to
just gotta
the
add the coefficients on both sides that you need.
Okay, so what coefficient do I need?
You
You
need
have
a
to
3
put
on the
3.
Mg and the 2 on the Fe.
Okay,
Yeah.
good job. Okay, so now that we have a balanced equation, I'm going to remove this because I'll need the room. Now I'm going to write this is the conventional. Okay, so now I'm going to write the total ionic equation. Okay, so what is the rule about solid liquids or gases?
Solid will not disassociate.
Okay, so we're just going to leave it alone.
Leave it alone.
Okay, what about the iron 3 chloride?
Okay, that's going to disassociate.
Okay,
Yes,
into
that would
what?
be. I guess that would be 2Fe. Well, I don't know the charge. That would be 2Fe 2 plus.
Check with Isaiah.
Are you sure 2 plus? What does this mean?
Oh, okay. 3 plus.
3.
Okay. Yeah, don't forget the rules. Okay, aqueous. And what else?
Cl 2Cl3 minus.
Now remember, since you no longer
Wait, why do
have
we have the 3 plus?
because the charge on the iron,
Oh, okay, fine.
it's because remember it's separating, right? So if it's separating, the only thing that's holding these chlorines and these iron together are the charges. Now you just separated that positive charge. So what's going to happen to your chlorine? Are they going to be held together?
Okay. Well, I thought I was just going to say like 2Cl3 minus or something. Is that not right?
Nope.
So there's
Because
nothing to
are
bond
they,
it, so it's gonna separate?
they're going to separate it because it's an ionic bond. The only thing that's holding them together is those positive and negative charges. So your negatives are going to be able to act independent. But then if I have negative CLs, how many am I going to have?
So it's gonna be 1.
Would it be 1? How many
6.
total do I have?
6.
I'll have 6.
Wow, this is confusing actually.
Okay, so.
Oh, I just completely ignored the coefficient, my bad.
Okay, so if you look at it like this, right? So we have your iron here. Your iron is connecting to the CLs. Okay, so soon as you break up the iron and the CL, each of your CLs are going to be hanging on by themselves. You no longer have that connection between the iron because you broke them up with water. Okay, so then you end up with your 3 CL minuses and your 1. Okay, now, but you have 2 of these guys, so you're going to end up with 2 FEs and a total of 6. Yeah. Okay. Okay, so now what's going to happen here with the magnesium chloride?
Okay. I guess that's 3 Mg2 plus.
Thank you. Okay.
And 6 Cl minus.
That's right. Plus, we leave this guy alone. Now remember, it has to be exactly the same on both sides to count as a spectator. So, who's going to be a spectator?
Fe. Iron.
Are you sure?
Would it be
Look at it. It has to be exactly the same. I heard somebody, would it be?
just the chlorides?
The chlorides. Exactly. It's just going to be the chlorides.
What of the magnesium?
Look at the magnesium. This guy, does it have a charge over
Okay.
here?
Yeah.
Does this magnesium have a charge associated with it?
No.
No, it doesn't. But this one does. Are they exactly the same?
No.
Nope. This iron, it has a charge associated with it. Does this iron over here? Okay, but they're not exactly the same. So these would be my spectators. Okay, so we remove our spectators, and then we're just left with our total ionic equation. Okay, which is just going to be EMG S plus 2Fe3 plus and that's going to yield 3 Mg 2 plus plus 2Fe S. Okay.
I have a question. So, for example, if the magnesiums had the same charge, would they be the same even though one is a solid and one is an aqueous?
No, they wouldn't be the same in that case.
They wouldn't?
Would not. No. But that most likely won't happen. Usually, magnesium is always going to be magnesium solid if it doesn't have a charge associated. If it's in its ionic form, don't get me wrong, there are going to be occasions that it will, but it's rare. Put it like that.
Oh, thank you.
Does that make sense?
Yeah, that makes sense. I just was wondering about that.
Yeah. If their state is different, if one is aqueous and one is a solid, then it's not the same. Okay.
Dr. Henry, the last equation that you just wrote, is there a specific name to it or?
Yes, it's called the net ionic equation.
Oh, okay then.
Net ionic equation.
Dr. Henry, as you mentioned earlier about the spectators, or I don't know if I mispronounced that word or maybe.
No, you pronounced it right, spectators. That's right.
Okay, since the chlorines were identical, does this mean that when if we are going to write the net ionic equation, that means the chlorines would be eliminated then, right? Since they were
Exactly. Yep. You eliminate all spectators. Yep.
Okay then.
Okay.
Yeah.
Okay. Okay. So let's go back. Okay, so we have this equation here where we have our total ionic equation, right? Now, if you look at this, the charge that's associated with the magnesium is 0. The charge that's associated with the magnesium ion is a +2. The charge that's associated with the iron is a +3, and the charge that's associated with the iron here is a 0, right? And so the total charges, if we take a look, is going to be over here. It's going to be a +6. And then also over here, 2 times that 3 is going to be a +6, right? So now, but we're going from a 0 to a +2. So if we're going from a 0 to a +2, what must be happening to that magnesium? Is it going to be losing electrons or is it going to be gaining electrons? If we're going from a 0
In the backyard, is there?
to a +2.
Losing.
Okay, so we're losing electrons.
Oh.
Okay. Now, the iron is going from a +3 to a 0. So if it's going from a +3 to a 0, that must be doing what?
Gaining.
Okay, so this guy is gaining. Okay. Okay, so there's oxidation reduction. Anytime that you're losing electrons, that's called oxidation. And the way I remember is loss of electrons, oxidation. And if you're gaining electrons,
Reduction.
that's right. Okay. And at the end of the day, the number of electrons that are gained and lost should be equal to each other because they should balance out. Because you're going from one is gaining, the other guy's losing, right? So this guy, if we look at it, this guy is losing electrons. This guy is gaining electrons. Okay. And they should balance out, the total number should balance out. So we have 6 and 6 going each way. Does that make sense? You got it?
Makes sense.
Okay. Okay. So an iron nail is dropped into a solution of hydrochloric acid. Okay, so now you need to tell me what is going to be the reactants, and then we're going to predict the products based upon all the knowledge that you guys have. Okay, an iron nail is dropped into a solution of hydrochloric acid. So what is going to be the chemical formula? What is going to be my conventional equation?
Starting with Fe.
Okay. So we got Fe, solid, liquid, gas, or aqueous.
Solid.
Okay. Plus HCl, solid, liquid, gas, or aqueous.
Aqueous. Okay, the product.
Our product, yep.
Hey, that should be FeCl.
Okay, so we know that iron is a transitional metal. So when transitional metals, when you replace one metal for another metal, and it's a transitional metal, or you're replacing transitional metal for hydrogen, typically the charge on that metal is going to be a +2 charge. If it's a transitional metal, okay? The only exceptions are going to be silver and aluminum. Okay. So if that's the case, if it's Fe2 plus, how many chlorines am I going to need to balance it out?
2.
2.
Okay.
FeCl2.
Okay. And it's going to be
Aqueous.
aqueous. Okay. And then now we have those hydrogens, and we know that if it's hydrogen by itself,
H2.
That's right. H2.
H2.
That's right, because we
okay.
know that hydrogen is what? When it's all alone, it has to be
Diatomic.
diatomic. Yep.
There's so many things to remember in one little equation. It's too much.
Oh, it's not too much. You can handle it.
Yeah.
You guys can remember songs to all of these different, you know, you can remember the lyrics to all of these different songs, and you can remember all the characters to, you know, all of these different shows. And you can't remember this? Come on now.
Those ones are easy. They are like fun, so it doesn't take you anything.
This is fun. And
Sometimes. Sometimes.
Okay, is it balanced?
No.
What do we need to do to balance it?
Add a 2.
In front of.
I like that. Add a 2. Where am I adding the 2?
Acid.
HCl.
Okay, is it balanced now?
Yes.
Yeah.
Okay. Okay, so now I'm going to ask you, what is being oxidized and what is being reduced? Okay, so if the iron is starting off at 0, and then when it's in solution, I mean, when it's with that chlorine, oh, I guess we should finish. Let's finish the equation. So now we have a balance. So let's do the total ionic equation. That's conventional. I got carried away. It's getting ahead of myself. Okay, total ionic equation. Let's see, who's my victim? Let's see. Nate.
He's here.
Daniel. Finley. Are you there? Okay, not answering. Catherine, are you there?
Yes.
Okay, so what are we going to do here with this iron?
I'm having a little bit of trouble. I've been watching and I'm having a little bit of trouble.
Letitia, you want to help her out? What are we going to do with the iron?
It's going to stay the same because it's solid.
That's right. It's going to stay the same because it's solid. Okay, Jalissa, tell me about hydrochloric acid. Is it a strong acid?
Hydrofluoric acid? Or hydrochloric? Yes.
Hydrochloric acid. Is it a strong acid?
Yes.
Yes. So what do we know about strong acids? Are they going to dissociate or are they going to stay together?
They're gonna dissociate.
They're going to dissociate. So what are we going to get? In the case of hydrochloric acid, we're going to get what?
I don't know.
Jamie, you want to help her out?
What's the question again? I'm sorry.
I said, so she says that hydrochloric acid is going to dissociate. What is hydrochloric acid going to dissociate to?
It's going to dissociate to. Give me 1 second.
Okay, Pedro, are you there? Ramon? Sergio? Tucker?
I knew I was coming. Okay, what was the question?
So what is it going to dissociate to? We have hydrochloric acid dissociate. We've already established that it dissociates. What is it going to dissociate into? So if it breaks up, what's going to happen?
Okay, so it's into Fe.
We got the hydrochloric acid. What happened to like chloride? And
wait, say that again.
I said, what happened to sodium chloride when it was in water?
When the sodium chloride, it dissolved.
Okay, and making what? What did it dissolve into?
Hydrochloride.
Would it be 2 hydrogen plus
Okay.
aqueous and then plus 2 chloride negative aqueous?
Okay, so it's just going to break up into its ionic compounds, right? Or its ionic components. It's going to form that H plus, those 2 H pluses, and those 2 Cls. Anytime that you have stuff in solution and it's able to break up, it's going to break up, right? Water is a good home wrecker. Good job, Brianna. I see it a little bit late. Okay, so what's going to happen on the other side of the equation? Tucker, what's going to happen to iron chloride? Think about just the example we gave, right? Isn't it aqueous?
Yes.
Okay, so what's going to happen? It's going to do the same thing that's happened over here.
It's going to break up into, gosh, I don't know. I'm confused.
It's going to break up into, what's going to be the charge on the iron?
Cl2.
The iron.
What
is the charge on Cl? Where's Cl located at? How far is it from being a noble gas?
1, negative 1.
1 away. So it's going to have what charge associated with the ion?
Negative 1.
Negative 1. And there's going to be 2 of them, right?
Oh.
Balance the iron.
And the iron is going to have what charge?
2 plus.
2 plus. Okay. See, Veronica. And then we know, what do we know about that gas? That the hydrogen gas. Are we going to do anything with that?
No.
No, so we're going to leave it alone, right? Okay, so who are my spectators?
2 Cl. 2 Cl.
That's right, 2Cl. Okay, so our total ionic equation is going to be what?
Fe solid. Everything minus the chlorides.
Everything minus the chlorides, that's right.
Wait, that middle equation is What would that equation be called?
Total ionic equation.
And then the last one is the net ionic equation. Okay.
Okay. So this guy's going from a 0 to a +2 charge. This guy's going from a plus to a 0 charge. So which one is being oxidized and which one is being reduced?
Iron is being oxidized and hydrogen is being reduced.
Okay. Questions, concerns, cash, cryptocurrency.